In chemistry, a carbonate is a salt of carbonic acid, characterized by the presence of the carbonate ion, CO2. The name may also mean an ester of carbonic acid, an organic compound containing the carbonate group C, equals O2. The term is also used as a verb, to describe carbonation, the process of raising the concentrations of carbonate and bicarbonate ions in water to produce carbonated water and other carbonated beverages, either by the addition of carbon dioxide gas under pressure, or by dissolving carbonate or bicarbonate salts into the water. In geology and mineralogy, the term carbonate can refer both to carbonate minerals and carbonate rock, and both are dominated by the carbonate ion, CO2. Carbonate minerals are extremely varied and ubiquitous in chemically precipitated sedimentary rock. The most common are calcite or calcium carbonate, CaCO3, the chief constituent of limestone. Dolomite, a calcium magnesium carbonate CaMg, CO3, 2. And siderite, or iron, 2, carbonate, FeCO3, an important iron ore. Sodium carbonate and potassium carbonate have been used since antiquity for cleaning and preservation, as well as for the manufacture of glass. Carbonates are widely used in industry, for example in iron smelting, as a raw material for Portland cement and lime manufacture, in the composition of ceramic glazes, and more. Structure and bonding: the carbonate ion is the simplest oxocarbon anion. It consists of one carbon atom surrounded by 3 oxygen atoms, in a trigonal planar arrangement, with D3H molecular symmetry. It has a molecular mass of 60.01 daltons and carries a -2 formal charge. It is the conjugate base of the hydrogen carbonate ion, HCO3, which is the conjugate base of H2CO3, carbonic acid. The Lewis structure of the carbonate ion has 2 single bonds to negative oxygen atoms, and 1 short double bond to a neutral oxygen. This structure is incompatible with the observed symmetry of the ion, which implies that the 3 bonds are equally long and that the 3 oxygen atoms are equivalent. As in the case of the isoelectronic nitrate ion, the symmetry can be achieved by a resonance between 3 structures. This resonance can be summarized by a model with fractional bonds and delocalized charges. Chemical properties: metal carbonates generally decompose on heating, liberating carbon dioxide from the long-term carbon cycle to the short-term carbon cycle and leaving behind an oxide of the metal. This process is called calcination, after cal, the Latin name of quicklime or calcium oxide, CaO, which is obtained by roasting limestone in a lime kiln. A carbonate salt forms when a positively charged ion, M+, attaches to the negatively charged oxygen atoms of the ion, forming an ionic compound, 2M++ CO2, 3M, 2 company, 3, M2++ CO2, 3M CO3, 2M3++ 3 CO2, 3M, 2, CO3, 3. Most carbonate salts are insoluble in water at standard temperature and pressure, with solubility constants of less than 1A, 10A8. Exceptions include lithium, sodium, potassium and ammonium carbonates, as well as many uranium carbonates. In aqueous solution, carbonate, bicarbonate, carbon dioxide, and carbonic acid exist together in a dynamic equilibrium. In strongly basic conditions, the carbonate ion predominates, while in weakly basic conditions, the bicarbonate ion is prevalent. In more acid conditions, aqueous carbon dioxide, CO2, AC, is the main form, which, with water, H2O, is in equilibrium with carbonic acid. The equilibrium lies strongly towards carbon dioxide. Thus sodium carbonate is basic, sodium bicarbonate is weakly basic, while carbon dioxide itself is a weak acid. Note that although the carbonate salts of most metals are insoluble in water, the same is not true of the bicarbonate salts. This equilibrium between carbonate, bicarbonate, carbon dioxide and carbonic acid in water can, under changing temperature or pressure conditions, and in the presence of metal ions with insoluble carbonates, result in formation of insoluble compounds. This is responsible for the buildup of scale inside pipes caused by hard water. Carbonated water is formed by dissolving CO2 in water under pressure. When the partial pressure of CO2 is reduced, for example when a can of soda is opened, the equilibrium for each of the forms of carbonate shifts until the concentration of CO2 in the solution is equal to the solubility of CO2 at the temperature and pressure. In living systems, an enzyme, carbonic anhydrase, speeds the interconversion of CO2 and carbonic acid. Organic carbonates. In organic chemistry, a carbonate can also refer to a functional group within a larger molecule that contains a carbon atom bound to 3 oxygen atoms, one of which is double bonded. These compounds are also known as organocarbonates or carbonate esters, and have the general formula Racora or RRA CO3. Important organocarbonates include dimethyl carbonate, the cyclic compounds ethylene carbonate and propylene carbonate, and the phosgene replacement, Phosgene. Biological significance: it works as a buffer in the blood as follows. When pH is too low, the concentration of hydrogen ions is too high, so one exhales CO2. This will cause the equation to shift left, essentially decreasing the concentration of H+ ions, causing a more basic pH. When pH is too high, the concentration of hydrogen ions in the blood is too low, so the kidneys excrete bicarbonate. This causes the equation to shift right, essentially increasing the concentration of hydrogen ions, causing a more acidic pH. There are 3 important reversible reactions that control the above pH balance. 1. H2CO3, AC, H+, AC, plus HCO3, AC, 2. H2CO3, AC, CO2, AC, plus H2O, L, 3. CO2, AC, CO2, G, exhaled CO2, G, depletes CO2, AC, which in turn consumes H2CO3 causing the aforementioned shift left in the first reaction by Le Chatelier's principle. By the same principle, when the pH is too high, the kidneys excrete bicarbonate into urine as urea via the urea cycle. By removing the bicarbonate, more H+ is generated from carbonic acid which come from CO2, G, produced by cellular respiration. Carbonate salts. Carbonate overview. Presence outside Earth. It is generally thought that the presence of carbonates in rock is strong evidence for the presence of liquid water. Recent observations of the planetary nebula NGC 6302 shows evidence for carbonates in space, where aqueous alteration similar to that on Earth is unlikely. Other minerals have been proposed which would fit the observations. Until recently, carbonate deposits have not been found on Mars via remote sensing or in situ missions, even though Martian meteorites contain small amounts. Groundwater may have existed at both Gusev and Meridiani Planum. See also, oxalate, sodium percarbonate, peroxosarbonate, references, http, www.sci.org biobuffers HTML, Kemper, F., Molster, F.J., Jagger, C. and Waters, LBFM. The mineral composition and spatial distribution of the dust ejecta of NGC 6302. Astronomy and Astrophysics 394, 679-690. Scores al., doi 10.1126/science 1139045, Scores al., doi 10.1029/2006 J002771, external links, carbonate carbonic acid equilibrium in water, pH of solutions, buffer capacity, titration and species distribution versus pH computed with a free spreadsheet, carbonate. Dictionary.com. Retrieved April 5, 2014 A.